And that was where I was sort of leading to is if you look at products that go through a smokehouse, all processed meats companies, all companies that are making pre-cooked meats have the same three objectives. They want the product to be safe to eat, within the quality specifications they're looking for, but to maximize production.
Welcome to MeatsPad. In collaboration with the American Meat Science Association, it's a platform dedicated to share breakthrough knowledge that is accessible to the global meat industry. On each episode, you'll have the opportunity to listen and learn from meat specialists and professionals about the whole meat industry. This podcast is brought to you by the U.S. Meat Export Federation, Ultrasource, equipment and supplies for the meat and food industry, Viscofan collagen casings, the best alternative to animal gut casings for a better taste and sustainable sausage making, EFA, slaughter and meat processing tools.
Hello, meat folks. Welcome back to the MeatsPad podcast. Today we are recording the episode number 2 during the 76th RMC. And with us today, we have a gentleman with more than 30 years of experience in cooking, cooling, and thermodynamics. And we've had a lot of questions from meat processors on a smokehouse and how we make a smokehouse more efficient. I think we're going to touch here in a minute about some of the tips for small meat processors to take advantage of their technology. We want to welcome Bob Hanson, consulting engineer. Thank you for having us.
Oh, it's my pleasure. Thank you for having me.
A recommendation for meat processors when they're trying to pick the best smokehouse, what are some of the things that they have to consider when doing so?
Well, smokehouses are sort of a black box to a lot of people. They're not really sure what's going on inside the smokehouse, but all smokehouses actually control the same 4 variables. And so I just take everything down to sort of the first principles, which is a popular term now, but sort of the basics of what is actually happening to the product during thermal processing. And you've really just got 4 variables you're trying to control: the dry bulb temperature, the wet bulb temperature, the air velocity, and the time. And all smokehouses control those same variables. Dry bulb temperature is just the temperature of a dry sensor. So they call it dry bulb because it used to be a bulb of mercury, right? So if the bulb was dry, that was the dry bulb temperature. Wet bulb temperature is the temperature that moisture is evaporating. So what you do then is you take a moisture wicking sock and you put it over the wet bulb sensor, the bulb of the mercury in the case of mercury, but the end of the sensor, and the moisture evaporates from it at the wet bulb temperature. And so the difference between those two is how people calculate relative humidity. And then the third variable is the air velocity, the fourth is time. So when you ask the question, well, what's the best smokehouse? Well, the smokehouse is controlling those 4, so which oven is best at controlling those 4 variables? And so the key thing that I look for is 2 things. One is that they're measuring and reporting to you the wet bulb temperature. Many oven manufacturers make the mistake of calculating relative humidity and reporting that to you as if that was the most important variable. The most important variable is the wet bulb temperature itself. So it shouldn't be used just as a way of calculating relative humidity. You should actually be measuring and paying attention to the wet bulb temperature because that is the surface temperature of the product. Moisture is coming up to the surface of the product and evaporating at the wet bulb temperature. So the wet bulb temperature is controlling the rate of heating and the rate of drying, both. So it's super important to measure the wet bulb temperature directly and have that as be part of the program and have that be reported to you in the control system. So that's one key area, one key thing you need to look for. The second one is the air velocity over the product is going to be actually highly variable. If you look at, no matter how big the oven is, small or big, the product doesn't care. You just got one piece of product, the air is flowing across it, and that air velocity across that individual piece of product is all that piece of product cares about. It doesn't matter that there's 10 pieces in there with it or 10,000 pieces in there with it. It doesn't know that. It just knows what the air velocity is across it. And so the management of that air is really important. And so you want to look for a smokehouse that can control the air precisely across different parts of the oven. And that the variation that you get is another key part of differentiator among different types of smokehouses. So those are the 2 things that I look for: good control of air velocity and measuring wet bulb directly, not calculating its relative humidity and then leaving me in the blind as far as to what the wet bulb temperature actually is.
So I'm going to go back to the wet bulb, but first you mentioned air velocity, and I know there's some ovens, some houses that they do go horizontally and some others are going vertically. So do you have any depending on the product, maybe a good, like, what product are you making, but what would drive me or drive a processor, like what type of Smokehouse? Because depending on the brand, some of them they better are horizontally, maybe some of them are better with vertically. Maybe you can share more with that.
Yeah. So this answer is going to be a little bit of shock to you and some of your listeners, but the horizontal airflow ovens are frankly, none of them work very well. And it isn't at the fault of the engineers that designed them. It's because the engineers were given an impossible task. The horizontal airflow ovens have ductwork that has fixed airflow across the product to try and drive it horizontally through the oven. And that ductwork is unnecessary, and it's actually impossible to balance. If you look at a conventional smokehouse where you've got air delivered in two supply ducts, and that those two airstreams meet at the center and then flow up through the product, they all have either twin fans or they have a rotating damper system that causes that air to flow back and forth in the oven like a pendulum. And if you stop that at its peak, the air will flow horizontally through the oven. Someday we'll do a podcast that gets more into detail on that with some diagrams so we can actually look at that. But just me swinging my hands around in the air is what we have to do with now. But that air, when it swings around into the upper corners back and forth, if you stop it there, it actually is going horizontally through the product. So you don't need the ductwork. In fact, the ductwork is an impedance to that, is an impediment to that. So you actually want to have just your conventional airflow ductwork, but you want to have either pause timers in the case of a rotating damper system, or programmable variable speed drives in the case of a twin fan system, which is really the best and easiest oven to balance, is ovens that have two fans. And the reason is because when you do get that air up into the upper shoulder of the racks, like the upper right side or the upper left side, the air is going to flow across because the high velocity air pulls it across. So you end up with this kind of a circular motion of the air. And so there are many smokehouses that control their dampers so that you can stop at various locations. And there are other ones that have twin fans so that you can have one fan set at 100% and the other fan set at 50%, and that'll do the same thing. It'll drive the air through what typically is the slowest drying part of the oven, which is the upper set.
And I guess this is good, because then my next question will be, let's say for jerky, that you have a cart fill up with, 25 plus 30 trays. So that won't make a big difference, even with jerky, where you have maybe like this tall, maybe 1 inch for the air to go through those spaces. I don't know, because it's not the same smoking maybe like a pork ham than some jerky.
Yeah. The big difference between most products is whether they're hanging up, like a bone-in ham is the extreme on that side, versus jerky as you described, which is laying down on screens. Now, some jerky is hanging up too, but let's say the jerky is put on screens, or meat bars are put on screens. Anything that's put on screens needs to have the air flowing horizontally through it. But you do that by controlling the rotating dampers, not by putting in a bunch of ductwork that actually is, I have to be candid, it's impossible to balance. They're giving their engineers, I'm not saying it's hard, it's impossible. So it can't be done. It's like boiling the ocean. I guess you could do it, but it just isn't practical. So the most important thing is to have control of the air so that you can stop the rotating dampers at multiple locations, or you have twin fans that you can do the same thing. And the idea is to get the air to flow through those screens sideways, which it will if you stop it at that location. So let's use another example too. Let's talk about a product. The screen product is the one extreme. The other extreme is snack sticks that hang full length from top to bottom. In that case, you don't want the air flowing horizontally through there because you're hitting the product perpendicular. And when you hit the product perpendicular, it dries very fast. And then the product further interior is not getting that same kind of air velocity, and so it's drying very slowly. So now you've got fast drying product on the outside of the rack, slow drying product on the inside. So what you do to prevent that is you set up your airflow again. You set up a different profile so that the air can flow across just from the left corner of the oven to the right corner of the oven. And I use human terms so people can get it, but you want it to flow from ankle to ankle, just back and forth and back and forth. And that way the air flows parallel to the sticks, clear from the bottom, and you don't get that perpendicular fast drying rate, which would be great if you could get all the product to do that, but you can't because some of the product's in the middle of the rack. So in this case, our two profiles would be profile A, which would just get the air to flow back and forth from wheel to wheel in the racks, or from ankle to ankle if you picture it as a person.
And I'm sorry to stop you there, but I would like to ask you like a follow up on that. So let's think if they do it that way, the way that you suggest. No, why? What are some of the quality? I mean, how do you see that negatively?
Yeah. So there's two things that would happen. One is, there's several functional things that happen that are useful. If you do, I'm going to make sure I answer you, or I understand your question correctly. But if you do that so that you can have the air flowing parallel to the snack sticks, and we'll continue with the snack stick example, you're going to have the same color product from bottom to top, and it's going to be the same amount of wrinkling from bottom to top. If you didn't do that and you had the air flowing into the snack stick sideways, the outside would be wrinkled, the outside of the rack would be wrinkled, the inside would be smooth. The outside of the rack would be a dark color, the inside of the rack would be more of a pale color. So you'd have two quality problems: variable levels of wrinkling and variable levels of color. You can always get the product finished by just raising the wet bulb up to, and we'll get back to the wet bulb, I know, but we raise the wet bulb up above the target core temperature, or we steam cook. We can always get the product to finish temperature. We can even out the temperatures, but you'll still have those same quality problems. But by having the airflow, in the case of the snack sticks, from back and forth to from ankle to ankle, or from wheel to wheel, corner to corner, now the air is all flowing parallel across the product, and we don't have this. We have uniform level of wrinkling. We can get it to wrinkle as much as we want, and we have uniform color, because the product will still form. The color will still form at a different rate, but you'll get the color in the upper center, which is the slowest drying part of any smokehouse. We'll get that color without over drying the product on the bottom, because the air is flowing parallel across it. It won't hyper dry it. Now, if we go to the screen example again with the jerky, now we want the air to flow horizontally through it. So now we're gonna stop our air and have it flow horizontally through, right? So we're gonna stop at the two apexes, right? That's gonna be a different profile. Let's call that profile B. I want to have a smokehouse that I can choose that. I want to choose profile A for my snack sticks and profile B for my jerky, my meat bars, or log product, any product that's laid down on screens. But the vertically hung product, especially snack sticks being the most extreme, I want to have, let's call it profile A. So profile B then will bring the air up to the upper shoulder now, to use the human kind of humanizing analogy again. I want the upper outer shoulder. I want the air to stop there for 30 seconds, and then I want to move down and stop at chest level for 20 seconds, and I want to stop at waist level for 10 seconds, something like that. So that's what I want the smokehouse to be able to do, to be able to control the airflow by profile, so I can choose a profile for the different products that I'm running, so I can have a snack stick program and a screened product program, and those will have two different separate air profiles. That is not widely available. There's only a few smokehouse companies that do that, but it will become more pervasive if your listeners ask for it. Innovation will be pulled through if your listeners ask for it. And so that helps your listeners in that they can choose the right smokehouse, but also what they ask for, they'll get. Smokehouses are very expensive, and so if you say, in order for you to be in the running here, I need to be able to choose multiple air profiles for my different products, much more likely that the manufacturer is going to look at that and say, well, that's a good idea. Let's give that a go. It's just writing some software. It's not that hard. So that's where the innovation will come from. And the consumer drives the innovation by asking for that, right?
The mission of the USMEF is to increase the value and profitability of the U.S. beef, pork, and lamb industries by enhancing demand for their products in export markets to a dynamic partnership of all stakeholders. Simply put, USMEF is putting U.S. meat on the world's table.
Let's go back to the wet bulb, because I think this is important that we spend maybe another 3-5 minutes explaining what wet bulb is, because especially you're mentioning that that's the most important thing that you have to monitor, like the screen that you're looking at on your smokehouse. You have to be looking at wet bulb. Yeah. So maybe we can find for someone that just started a meat facility. Nowadays we have many people that have just started with a meat business, and maybe we can, in a more layman's terms, you can maybe explain that a little bit further.
Yeah, sure. So if we set aside the discussion of smokehouses and just look at the product now. So I've got one piece of product, and I'm in the slowest drying part of the oven, fastest drying part, that doesn't matter. So you're just one piece of product. So that product has moisture in it, and that moisture comes to the surface and it evaporates. It evaporates at the wet bulb temperature. So as long as that surface is wet, as long as it's moist, as long as it's fully saturated, the moisture is going to evaporate at the wet bulb temperature. So if I set my wet bulb temperature at 125 Fahrenheit, the moisture is going to evaporate at 125 Fahrenheit. It has no choice. The moisture is wicking up into a cotton sock on the wet bulb sensor, and it's evaporating from the wet bulb sensor. So the wet bulb sensor is always fully saturated, assuming it's functioning correctly. There's problems with wet socks. They can get clogged with smoke. There's different things that can happen. But if the wet sensor is functioning correctly, which most of the time it is, the moisture is going to evaporate from that fully saturated cotton sock at the wet bulb temperature. If you look at the product, the moisture is coming to the surface, and as long as that surface is fully saturated with moisture, it's also going to evaporate at the wet bulb. So you can control it exactly. The other key area, though, is if you measure the surface temperature. This is another thing to look for in smokehouses, is another innovation to ask for, is of course you want a core temperature probe, right? That's for food safety. I also want a surface temperature probe, and I want you to put that on a graph on the screen. There's only a couple of smokehouse companies that do that, and it's very useful because you can tell if the surface is dry or if it's wet by looking at the surface temperature and comparing it to the wet bulb. So if my wet bulb temperature is at 125, the surface temperature comes out to 125, that means it's still wet. So it absorbs smoke like crazy. That's good for smoke absorption. But what about color development and dehydrating? Yeah. So let's think about color development. Now, in this is where you can look at multiple podcasts here, because there's so many. Okay, now I've absorbed the smoke, but I want to develop smoke color. Smoke color is a Maillard-Browning reaction. Maillard-Browning reaction requires hot, dry conditions, not hot, wet conditions, hot, dry conditions. So the surface is wet because my wet bulb is at 125, my surface is at 125. Let's say I'm making bacon, for example. So I'm absorbing smoke like crazy, but I'm not going to develop any color. The Maillard-Browning reaction is also a flavor reaction. So I'm not developing color or flavor, but I've absorbed a lot of smoke. So you have to dry it. So you need to see that surface come up to 126, 127. And this is what I call the Nike swoosh. It actually looks like the Nike swoosh when you do it right. You'll see the wet bulb be at 125. You'll see the surface temperature right with the wet bulb on a graph, and then it'll break away in a Nike swoosh. And that's when it dries and develops color, that's when the smoke color develops. And the flavor comes at the same time. So and those things, obviously that's why we smoke things, right? Just to get the color and the flavor, and because it gives you eye appeal, and then it gives you the sensory of the flavor. So that doesn't happen until the surface gets dry. So you need to see the surface break away from the wet bulb temperature. Whether that takes 5 minutes or 5 hours, you need to see that happen. And you can't see that happen unless either you buy your own set of data loggers and do your own tests, which is what I do, or wouldn't it be cool to have that as production data just on the screen? I mean, why not? All you need is another sensor. You got your core temperature. You have to have that for food safety, no question about it. But for quality and production, maximizing or meeting quality specifications and maximizing yields, shortening throughput, surface temperature is what it's all about. Because by measuring that, you can tell if the surface is wet or if it's dry, which is key for quality and color development. You can also tell when you're over drying, which means you're using yield with no gain, with no benefit, no quality benefit. So we want to dry, but we don't want to dry too much. We want to dry just enough to get color, and then move into wet conditions again to steam cook or do whatever it is to finish the product up to the CCP, to the food safety temperature.
Before we started recording, you mentioned three components that I want you to elaborate more on that. This triangle, and maybe you can explain the relationship of these three components.
Yeah, and that was where I was sort of leading to, is if you look at products that go through a smokehouse, all processed meats companies, all companies that are making pre-cooked meats have the same three objectives. They want the product to be safe to eat, within the quality specifications they're looking for, but to maximize production. And so the food safety, if you think about that as a threshold, right? You want to exceed the threshold for food safety, but exceeding it by more than is necessary is there's no value in that. You just have to get over the hurdle, and that's it. Quality is more of a bullseye, right? You're trying to optimize it, so you're trying to hit a particular target. So whether you hit the 10 ring or the 9 ring or the 8 ring, you know, that's all up to the processor, what their quality specifications are. But you want a particular color, a particular flavor, and that's an optimum you're shooting for. So that's more of a bullseye kind of a thing. But you want to achieve the quality specifications without compromising food safety. So food safety always has to be the top line objective. And then from production, you want to maximize production. You want to go as fast as you can, producing as much product as you can without compromising quality and without compromising food safety. And so that's a maximum you're trying to achieve. And that's where we design these 4 smokehouse variables to try and do those. And so the whole production process is designed around that, but specifically to the smokehouse, you're trying to meet a particular food safety temperature. You're trying to get the right color and the right surface skin formation, snap, you know, there's a number of different quality things, the right texture, and then do those 2 things, but maximize production. And that's where measuring those 4 variables becomes so crucial, is that it, especially the surface temperature, food safety is core temperature, but the quality specifications and the production throughput are surface temperature, and yet it's not measured in a most conventional smokehouses. And that's back to your very original question. If I was going to design the ideal smokehouse, it would absolutely measure surface temperature, and I would put that on a graph on the screen so I could see it happen, and everybody operating that smokehouse could watch that happen, and you could see whether the product was wet or it's dry, because that's so crucial for smoke absorption, color formation, skin formation, texture, peelability, you know, all kinds of things come into play by measuring surface temperature, not core temperature.
When did I guess we almost get into the end of this episode, but when did this passion started? Like, because when I hear you talking, you're passionate about thermodynamics, and not until you work with it you understand the importance of. I mean, talking about production managers and like, yeah, it's Smokehouse, but you start getting into there's a whole world, yeah. Like thermodynamics and how you measure wet bulb, dry bulb, and humidity. It's not the same smoking here in Minnesota than with smoking in Mexico. There's a lot of factors that impact the cooking portion, but I guess this is gonna be the first one for maybe 2 or 3 more that we can touch, because in reality we need to get more in depth so they can fully understand this. But maybe you can take a moment to describe a little bit about when did you start this love for thermodynamics. I know you were telling me earlier that you get your electrical engineer bachelor, agricultural electrical engineer bachelor, and then a master's in meat science. So it's a combination.
Yeah, actually it was so my undergraduate degree is in agricultural engineering technology. And so as part of that training, thermodynamics was part of it. And I don't know why, but it was one of my stronger subjects. And so that doesn't lead you to meat science. I just happened to be working in the University of Minnesota Meat Lab, which is just 10 minutes from here. And so I was working in the meat science laboratory, but I was in agricultural engineering. And so when I decided I'd like to do something in this area of meats, the meat science professors has suggested that I look at thermal processing as a possibility. And so I ended up choosing to go to Iowa State for graduate school, and it was there that I was able to they had a data logger and they had smokehouses, and we actually set up and ran what ultimately became my master's thesis project, where I measured the surface temperature, the core temperature, and then 2 intermediate temperatures during cooking. And so my master's thesis then was heat and mass transfer during cooking. This is called heat and mass transfer, but that sounds kind of complicated. You have to think about what has mass that's transferring during cooking. Well, that's water evaporation. So it's very simple, really. It sounds more complicated, but that's what I ended up studying. But it was, to your question though, I still remember when I first measured the surface temperature and the core temperature. You have to take yourself back. This is the early 1980s. There weren't any data loggers. You couldn't even make a graph on a PC. So I'm graphing this stuff on graph paper, literally with colored pencils. I mean, it's comical today. Yeah. So now so I draw the dry bulb temperature on there, and because I've recorded these things, and so you're just putting them like we used to with a ruler and whatever. And then I draw the wet bulb temperature on there, and then I had measured the surface temperature on bologna. This wasn't typically done, right? So I measure the surface temperature, and it tracks right up with the wet bulb temperature. And I had a food engineer on my committee, right? So I make this graph of this first kind of preliminary test run, and I went to him. I had to trudge over. It was wintertime in Iowa, so I was trudge over to his office was in the food science building. I said, something's wrong with my temperature sensors. Look, the surface temperature is tracking right with the wet bulb temperature. I was confused by this, right? And he's a food engineer, right? He said, well, what did you expect it to do? Of course it does. And then it hit me and that's actually what started my my career in this field. Yeah, tracking the surface temperature with the wet bulb temperature. But that tells you everything. Of course it does. Of course it follows the wet bulb temperature, he said. And so then you look at that and you see that, and then smoke absorbs as long as you're tracking with the wet bulb temperature. The color forms after that. If you have too much drying, it's hard to peel. It'll develop a skin, which if you want snap is good. If you want a tender casing, it's bad.
I want to thank you for your time. I think this is going to be, and I want you to promise me that we'll be at least one more to touch more on what we discussed today. We thank you for being here, and I'm way more than excited for this episode. I think sometimes we don't take that time to understand this, but as you said, you got food safety, you got production, you want to maximize production, but without compromising quality, and that's the key.
Yeah. No, I look forward to several more. I would welcome that. I'm all in on it.